All right. In previous years of math, you've learned how to solve for missing angles, and sides of right triangles. But what about triangles that are not right angled? Okay. In order to solve triangles that are non-right angled, which is oblique, anything that isn't a right triangle is called an oblique triangle. We need some new tools. The first new tool that I'm going to introduce to you is the sine law. That's the easiest one, the one that most of us will prefer to use. Okay? The sine law is a proportion that compares the ratio of each side of the triangle to its included angle. If you don't understand the previous sentence, don't worry. You need no need to run for help. Just think of the sine law as the formula. So the sine law is stated below. This is basically sine law in a nutshell. So we're saying that, watch this, just look up here. Okay? If you were to take sine of angle D, so this angle here, and divide it by the side across from it, that is exactly the same as saying sine of E, this angle here, divided by the side across from that. And same with the last pair here, sine of F divided by F. So all of these would be exactly the same if we had numbers here, if this was drawn to scale. So I'm going to just ask you, if you want to, maybe watch me do this first, but this is one pair right here, because pairs are very important in this unit, particularly with sine law. So here you have one pair. Okay. Then you've got this pair here. Angle D goes with side D. And last but not least, you've got this pair right here. Works in the following scenarios. Oh, by the way, this is it for sine law formula. This is it. If you just want to have this on your study sheet and just call this sine law, you're good. You might want to have examples on there though. That's up to you. How to solve for sides and angles. It works in the following scenarios. Ready? It's check mark means you will have a number there. So imagine this triangle. You have a number there. You have a number there, and you have a number there. What I want you to focus on is the pair. There's a pair there, a known pair. You know the angle and the side across from it. You could have a scenario where you have two angles. So let's say you know this number and this number. So you'll know two angles and one more side. Do you see the pair in that case? There's your pair. The last one is not so obvious that there's a pair. Okay? That's when you have two angles and the side that connects those two angles. Okay? This is what I call the hidden pair. Why is it hidden? Do you remember, if you know two angles, is there a way to find a third one? We subtract them from 180, right? Because we know all three add up to 180. So technically you know this one. So find third angle using sum of triangles equal to 180. Okay? So technically you do know that one. It's just a little one step away from you determining that. And there's your pair again. And which means, okay, this is what I'm trying to say here. If you're able to somehow find a pair you know it's going to be sine law, because later on we're going to talk about cosine law. And there it is one more time. Remember, I would put this next to sine law, to be honest. Or very short, like have a pair, it's sine law. Okay. So I would honestly not recommend having all of this on your study sheet. Just tell yourself you need a pair. That's all. Okay, let's put it to use. Let's actually use it. Do some math now. So the trick will be to find the pairs. That's all. Because the triangles look kind of wonky sometimes. Okay. So let's go to page 5. I'm first going to teach you how to solve for side lengths, because that one requires less work. I'm just gonna, for now, for this page, I just have the sine law still here. But remember that the letters will change, so don't be fixated with the letters. You're listening, right? Patterns, that's what you're gonna look for, patterns. What's the pattern? The pattern is that if you use the angle, then the side across from it needs to be down here. That is what I really want you to get from the formula. What does it say here? Note. If you're given two angles, you go ahead and find a third angle using the sum of triangles 180. Note, sine law works on right triangles as well, so that's the good news here. Sine law and cosine law will solve for oblique and right triangles, so we no longer have to use SOHCAHTOA. All right. So it says here, calculate for the length of side A. Imagine for a second there were no letters there. All you had were the capital letters. I would assume you would know, okay, this is capital A, so lowercase a is right there. That's what they're asking me to solve for. So sometimes they give you more information, sometimes less, okay? Then you ask yourself, I'm going to look at this and it's like, is there a pair? It's actually wide, like right there. It's wide in the open. Like you know this one, and you know that one. So you have your pair. Sometimes I see students, maybe you were sleeping during my lesson. Oh, there's a pair right there, 52 and 72. No, I mean like angle and the side across from a pair, okay? That's what I mean by that. So we know it's sine law. So here we go, let's use it. So the way I set it up, folks, is I go sine of that angle, sine of 52, divided by the side length, which is 16.8 centimeters. It's going to be equal to another pair. But one of those, I don't know what it is. So let's go over here. This is what we want to find, correct? So that's my side length. That's going to go down here. Do I have the angle opposite to it? Absolutely, I have 72. So it's actually a slam dunk. Like there's not much additional work you need to do here. Yeah, it's cross multiply and divide with some scary numbers. These are all numbers, guys. Don't worry about it. So A, right, you go to the side where the variable is. You start up here. Your journey begins by multiplying. And then once you get that answer, you divide it by what is left. This is not work. The arrows are not work. That's just to help you figure this out. I go 16.8, like I multiply these two, like that. And then I divide by what is left, sine of 52. And there you go. This is where a good calculator is going to be extremely important in this unit. I don't know if anybody's asking, Mr. Erickson, if you start your journey here, why don't you go sine of 72 times 16.8? It really doesn't matter, because 2 times 3 or 3 times 2, when you multiply, it doesn't matter. I like to have the number in front so that the 72 doesn't get mixed up with the 16.8. That's the only reason. So just make sure you multiply them. Make sure now, when I multiply and you multiply and I hit equals, are we getting the same number? Okay, then we're going to divide by sine of 52. And if you're using your calculator and you're like, mine doesn't work like that, Mr. Dirksen, hang in tight. I'll come and see you, or you come and see me later. But this is the side length there. Does it make sense? Well, what I mean by does it make sense is this is a smaller angle than that, correct?
Yeah.
The bigger the angle, the longer the side across from it will be. Got it? So if this is 72, then the side here should definitely be longer than 16.8, which it is. So I want you to check a little bit. Yeah. Significant. So yeah. So when I do 16.8 times sine of 72, it's a good question. I'm using all decimals there. So I don't want you to, if some of you like to do the top and then write it down, I don't want you to round. Only until the very end you round. It's a good question. So when you watch me do all the steps in this unit, I always take care of the significant units. I always use everything, so you don't lose any rounding marks. That's a good point. So then I go sine 52. So it's dividing by all of sine of 52. Because remember, sine of 52 is actually 0.78, right? Like it's a number. So I'm using all of those when I divide straight by sine of 52. Okay? Okay. What else? What does it ask next? Calculate the length of side C. So now we want this one up here. Guess what I do, folks? I use the same pair that I got from the very beginning. I don't mess with that. I like to keep the one that I knew just in case I made a mistake. Because guess what? Do you have another pair now if you find A? Absolutely. Could you in theory use that one? Absolutely. But I tend to stick with my original pair. Okay? So, watch this. Sine of 52 over 16.8. Can I want to find side C, correct? Do I have what I need up here? I don't know angle C yet, do I? But I do know two angles, so it's just a matter of figuring out what it is. So angle C is 180 minus 72 minus 52. Angle C is therefore 56 degrees. I use sum of a triangle. This is just my short explanation for what I've done here. So you plug in that 56. Please don't just do this. See, a lot of students just go, oh, 56. It's an angle, correct? It needs to be glued to sine. Okay? It's like the chaperone of 56. And now, cross multiply and divide again. So you cross multiply and then you divide. So C is 16.8 times sine of 56. So you multiply these two. And then you divide that answer by sine of 52. So we're using the property of the sine law to determine missing dimensions. So 16.8 times sine of 56 equals, I hit equals at that point, divided by sine of 52. So 17.67 is my answer. Does that make sense? Watch this, right? If this is 56, I can now write it in here if I want. This one is slightly bigger than that one, right? Can you see? So 52 has a side of 16.8 across from it. 56 should have a side that's slightly longer than that, which it is. It's 17.67. You have actually solved the triangle. Did you know that? So let's make a note. We solved the triangle. We know all sides and all angles. We've solved, you solve for all sides and all angles. All right. I'm going to ask you to give this a try already. So it's kind of, I know it's kind of scary already, but I think you can do it. I have full confidence in that. So I want you to go to page 6 and give that a try. Can I just do one more thing? You decide if you want to do this, but this is my original pair here. Okay? Same as this one here. This is my original pair. I started with the original pair in both instances, right? I'm still talking about the same triangle. You just have to make sure you get that part. Okay, page 6, what does it say? Solve for the following triangles. It says solve the following triangles. So we're going to go to page 6. We're not going to do all of them. I just want you to honestly try one or two. I'm going to give you the answers. So in this case, it says solve for Z. So how about we only solve, you're listening, right? You only solve for the missing side, like the one they're asking for. We're not going to solve the whole thing. Just so this case would be Z. Next would be M. And then the last one is asking for P. Right? So let's try those. So don't worry about solving the triangle unless you're done all of it and you want to go back and start from the top and then solve for that side X here, for example. Right? So you can do more if you're done, but for now, just the question marks, all right? So just work a little bit. I'll come around and see if you need calculus. You can't blame me for that, right? I usually give lots of examples, I hope. I'll read the survey and know for sure. Okay, so there's your pair. Because remember, in a couple of days from now, you're going to know cosine law. So you're going to have to decide which law. Only one works at the beginning, only one. So because of this pair, I know this is sine law. Okay, without a doubt, it's sine law. So I'm going to start with that. So sine of 40 over 36.3 centimeters. And here you have to be careful. If you use 34, then you're actually solving for side R, right? You're solving for this side. But if you want side P, you need to first find angle P, which isn't a problem because you already know two angles. So then it's just a matter of finding out that it's 106. This is usually worth a mark for the province. I'm telling you, it gets kind of ridiculous sometimes with the mark. If they see sine anywhere, you would get a mark already. Then you'd get a mark for this. You'd get a mark for setup and a mark for final answer. So oftentimes these are worth 4 marks, which I find a lot of marks for not a whole lot of work. So you got to be careful. So it's fairly straightforward. At the same time, you have to be careful. So I'm going to use this one, sine of 106. Because this angle is across the side I want. So now I can say I'm solving for side P. So 36.3 times sine 106. And sometimes it's a decimal, right? We don't round our angles to a whole degree. Maybe you did that in the years past. We still round angles to 2 decimals. You'll see that. This gives you 54.29 centimeters. I'll post a key, like I solved all triangles on my key, so I'll try to post that key. That way you know where you're at. And maybe at the beginning you need to do this for yourself, right? This is my pair. That's why I started with that. And this is technically a pair. I just don't know. I didn't know that angle just yet. I had to figure that out. And so you're pairing things up always to solve for the unknown. It's not a very good contrast, right? But anyways, let's solve for angles. So this is how you solve for sides. Let's do angles. It's very similar at the beginning. It's just one extra step. Do you remember sine inverse? Do you remember taking the inverse? That's the extra step when solving for angles. All right? So we'll go there. And then basically you know how to use the sine law now. That's all that there's to it. But make sure you practice it because there's little nuances, right? Okay, page 7. Calculate, the sign out to calculate for angle measures, for an angle measure, right? So, you're provided with this scenario. You've got a pair. Therefore, sine law. I don't know if I ever told you that the 3 dots is therefore. So it's sine law, okay? All right. It says at the top, it tells you what to do. Calculate the sizes of angle A and angle C. Let's start with our pair. That's our pair. All right. Then I go equals. What should I solve for first? Like I have this side length there, which will allow me to solve for which angle? Yes, remember they're pairs. So I'm going to put the 91.6 meters there. And at the top I'm just going to go A, right? That's an error, exactly. I don't know if you've already picked it up. It's right here. That's a very common error that students just put an A down. Okay? It's sine of A when you're trying to solve for an angle. Okay, that's still your unknown, okay, folks? We don't know what this is. So we start on the right side down here. So we're going to multiply up and then divide on our way down. So sine of A is 91.6 times sine of 81 divided by 123.2. I don't like trains normally, like equals, 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 but it is actually accurate to say that in this case. So I'm going to go 91.6 times sine of 81 equals, and I'm going to divide it by 123.2. And that's what I get, 0.734, and I'm not, keep it on your screen, don't erase it. Okay, I'm just going to write down a few decimals here. And you go dot dot, indicating that you're planning on using all numbers that are on your screen. This is where it changes. It started off with sine of A, right? As soon as you go angle A, you on this side, the inverse shows up, okay, of that number, the decimal you just found. Yeah, it's often in brackets. Your calculator will usually have brackets next to sine inverse, but this is what I do. I leave this on my screen. I press shift or second function, whatever your button is, to access whatever's above sine. Right? I press it and then I can hit equals and it will just do it for me. Okay, so 47.25 degrees. 47.25 degrees. I know it's weird. Angles to 2 decimals? Yes, we need to, that's what this course is all about. 2 decimals is the minimum. Precision measurement, we don't round, but 2 decimals everywhere else for your final answer. So this is your answer for this. I will just say take sine inverse. Okay, if you all right. So now on to angle C. I kind of used up a lot of space. I'm just going to do C up here. Up here. Do we know 2 angles now? You saw, right? So I'm just going to go angle C is just going to be 180 minus 81 minus 47.25. So I subtract the two angles that I know of this triangle, and I'm left with angle C, which is 51.75. Clearly indicate that's angle C right there. So, yeah. Whenever you have two angles, you can easily find the third. Okay. Calculate the length of side C. Can we do that now? Absolutely. I'm going to start with the same pair that I had before. But now I'm going to use sine of which angle? Angle C, the one I just found here. And now this turns into just a regular sine law where you find the side length. Cross multiply and divide. So I don't know if on your study sheet you want to have, this is the sine law, and then you have one example of each, solving for the side, solving for the angle. I don't know if you can manage to fit that in. Don't tell me I didn't solve for that here. 97.96. There we go. So you now know, hopefully, how to use sine law using solving for either angles or sides. I'm going to ask you to practice on page 8 3 questions. That's all I'm going to assign. So page 8. It says calculate the measure of the indicated side and or angle. Right? So that I'm mixing it up there. So if I post more pages, that's up to you if you want to do the rest, but I'm pretty sure I'm just going to post page 8. And maybe even page 6, the one where if you solve the whole thing,